I just simply shift this point charge by distance r around z axis and try to find the potential and electric field. Right? How do I do that? So I need to find potential at a variable point, which is the distance r from the origin, and the charge is shifted along z axis. So this is something like rz cap. So this distance, what is the distance then?
R minus R. R minus R.
rz cap. Right? I need to find the potential at the point R, which is straight meeting here. So I would try to do it by direct integration. So I need to find out what is the corresponding charge density. So I just 1 by 4 pi epsilon naught integration rho r d3 r prime r minus r prime. That's my plan. What is the corresponding charge density? Yes, Anil. I have just shifted along z axis. I have to write it in terms of delta function. Delta x, delta y, delta z minus 1. Why? X equal to 0, y equal to 0, z equal to r. I have a finite system. When I integrate, you should give me q. So therefore, the corresponding rho r is q delta x, delta y, delta z minus r. Z minus capital R. But I don't want to do this same Cartesian, very, very difficult. What is the corresponding symmetry in this problem? यह हो सकता है इसमें, लेकिन बहुत मुश्किल होगा इंटीग्रेशन। R minus J. So what is the symmetry क्या है? Formula दे देता हूँ क्योंकि I don't think people are conversant with this Dirac delta conversion. Let me just give you some formulas and you do it on your own. We'll come back to this. So let's see just give out this final formula that we need to Dirac delta conversion. So if I have a spherical shell of radius r with constant charge density sigma, what would be the corresponding rho r? Spherical shell with radius r and charge density sigma. What would be the corresponding rho r? Yes, sir. Del r minus capital R sigma. Right? This is the thing. Yeah. So remember the two things. Del is always goes as 1 by r. Right? And this sigma is already 1 by r square. So this is coming as the correct value. This is 1 by r cube. This is the correct representation. And one more thing, how do you convert CGS to MKS? Remember? CGS to MKS. Epsilon naught is replaced by 1 by 4 pi. Epsilon naught is replaced by 1 by 4 pi. Therefore, in CGS, so 4 pi epsilon naught cancels out. Right? So this is CGS to MKS, but this is spherical shell R sigma. The corresponding rho r is this. And what about the potential and the electric field? You want to find out potential and electric field. I'll leave it to you. Infinite long wire. Infinite long wire. What would be the charge density and what would be the phi r? Phi r you integrate. I'll show you how to integrate this. But what would be the charge density? infinite long wire. No one. So line charge density lambda divided by twice pi rho tilde delta rho tilde. In charge density, this is your radial vector, cylindrical polar coordinate, radial vector. Why is this 2 pi there? Integration करके वो करेंगे, right? So this is the charge density and the corresponding potential. Please find out. I can write down the answer. So this is minus 2 lambda divided by 4 pi epsilon naught ln R, infinite long wire. Potential of a charged disk. So this was your quiz. Please now actually ask this question. What is the charge density? Charged disk radius R. This was when you charge disk, the radius is R. How do I write rho R? कोशिश तो करो. Why this? Charge is present till capital R. After that it is 0. Right? And remember the Dirac delta function, whatever etc R or whatever, it is always giving 1 by R. So what would be the corresponding charge density? Sigma del Z. Because it is on the Z equal to 0, del Z. And theta R minus 1. Theta R minus 1. This is a step function. Doesn't have any dimension. So this is non-zero when R is smaller. This is smaller than capital R, and it is 0 when this is greater than. This is a step function. And why is the sigma set? Because only at Z equal to 0 you have charge density. So this is the corresponding rho R for a charged disk. The potential is sigma by pi epsilon naught root over R square plus Z square minus W square. I'm writing down the formulas, assuming that you will try with this charge density regulated. Okay, so let's come back to this problem. So our motivation is what we'll slowly go to our dielectric, polarization, dielectric constant and all these things. So towards that, first of all, I want to define what is called dipole moment. And towards that, I am first trying to do this problem of a point charge shifted along their axis. Does dielectric have a lot of application? Dielectric कहाँ आता है? Application कहाँ? Capacitor. And what else? All these wires, right? All these wires is coated with the material. Will it have high dielectric constant or low dielectric constant?
High dielectric.
तो all these wire है एकदम खरीदते हो, उसके ऊपर कुछ कॉपर तो एक्सपोज नहीं है, उसके ऊपर कुछ मटेरियल लगा हुआ है. Should that material have high dielectric constant or low dielectric?